For centuries, Enceladus was just a faint point of light, barely distinguishable from the countless other specks scattered across the night sky. Astronomers, peering through their telescopes, could only guess at what lay on this distant icy moon. It was a tiny, icy moon orbiting Saturn, overlooked and unremarkable, lost in the grandeur of its giant parent and the dazzling rings that surrounded them both. For generations, Enceladus seemed destined for obscurity, a frozen relic in the shadow of Saturn, with little to distinguish it from the many other moons in the solar system. But the universe loves surprises, and Enceladus was quietly hiding secrets beneath its icy shell, secrets that would one day rewrite our understanding of where life might exist. Our journey of discovery began with a faint anomaly, a subtle, almost imperceptible whisper from the cosmos that would soon become a roar, capturing the attention of scientists around the world. The arrival of the Cassini spacecraft marked a turning point, opening a new chapter in our exploration of the Saturnian system. Cassini's mission was to study Saturn and its moons in unprecedented detail, but when it turned its sophisticated instruments toward Enceladus, it found something astonishing, something no one had expected. Instead of a dead, frozen world, Cassini found activity, plumes of water vapor erupting from the surface, warmth beneath the ice, and signs of geological life stirring in the darkness. Suddenly, this tiny moon was thrust into the scientific spotlight, challenging everything we thought we knew about where life could exist and what conditions might make it possible. Enceladus became a beacon of possibility, a prime candidate in our search for life beyond Earth, inspiring new missions and igniting imaginations everywhere. Its transformation from a forgotten dot to a cosmic beacon is a testament to the power of curiosity, the relentless pursuit of knowledge, and the surprises hidden in our solar system. And it all started with a single unexpected observation, a reminder that even the smallest worlds can hold the greatest mysteries. In 2005, the Cassini spacecraft made a daring, close flyby of Saturn's icy moon, Enceladus, a world that had long been overlooked in the search for life beyond Earth. During this historic encounter, Cassini detected something no one had predicted: a massive, shimmering plume erupting from the moon's south pole, shooting material hundreds of kilometers into space. This was no ordinary sight. Until then, scientists believed icy moons were cold, dead worlds, certainly not geologically active, and definitely not capable of launching geysers into the void. But these plumes weren't made of molten rock like volcanoes on Earth. Instead, they were composed of water vapor and fine ice crystals, hinting at something extraordinary beneath the frozen surface. Enceladus was acting like a cosmic snowblower, flinging its own material into space and feeding Saturn's E-ring, creating a shimmering halo around the planet. This discovery shattered old assumptions about where life might exist and hinted at a hidden, warm environment beneath the moon's icy shell, a place where liquid water could persist. Where there's liquid water, there's potential for life. Suddenly, Enceladus became one of the most intriguing places in the solar system. NASA quickly adjusted Cassini's mission, sending the spacecraft directly through the icy plumes to sample their mysterious contents, a bold maneuver that would change planetary science. Each daring pass revealed more secrets: organic molecules, salts, and even tiny grains of silica dust, all ingredients that could support life as we know it. The plumes offered a direct sample of Enceladus's hidden ocean, making it a prime target for astrobiology and the search for extraterrestrial life. For the first time, scientists no longer had to speculate. Enceladus was serving up its secrets in a spectacular spray of frozen mist right into Cassini's instruments. The great unveiling had begun, and the world was watching as new discoveries poured in, captivating the imagination of scientists and the public alike. Cassini's discovery turned Enceladus from a distant curiosity into a scientific sensation, sparking new questions and inspiring future missions. The search for life in our solar system had a new, unlikely focus, one that continues to inspire wonder and exploration today. The plumes raised a crucial question. Where was all this water coming from? Was it possible that beneath the frozen surface, something extraordinary was hidden? Gravity measurements from Cassini revealed the answer. Enceladus's icy shell floats atop a vast global ocean. This ocean stretches beneath the entire surface, encasing the moon in a layer of liquid water. This wasn't just a few underground lakes, it was a true water world, with more water than many places in the solar system. The evidence pointed to a dynamic environment where the ice above shifts and cracks, allowing water to escape into space. Deep below, hydrothermal activity at the ocean's floor stirs the water, creating energy-rich environments. Silica nanoparticles in the plumes suggested hot vents, like those on Earth's ocean floors, where life thrives without sunlight. These vents could provide the heat and nutrients needed for life to begin. Enceladus has all the key ingredients for life: liquid water, energy from hydrothermal vents, and essential chemical building blocks. Complex organic molecules have even been detected in the plumes, hinting at rich chemistry. Its ocean is thought to be surprisingly benign, with stable conditions that could last for millions of years, with conditions similar to those where life began on Earth. The parallels are striking, fueling scientific excitement. This small moon was no longer a frozen wasteland. It was a potential cradle for life, a place where biology could take hold in the darkness. The discovery of a global ocean elevated Enceladus to the top tier of habitable worlds, alongside Mars and Europa. Suddenly, the search for life in our solar system had a new, promising destination. Scientists everywhere turned their attention to this icy moon. Enceladus was no longer just a moon, it was a world of possibilities. The implications were staggering, opening a new chapter in our quest to find life beyond Earth. The source of Enceladus's plumes: 4 massive fissures near the South Pole, known as the Tiger Stripes. These deep cracks reach through the ice to the ocean below, acting as vents for the moon's geysers. Cassini's infrared data showed these regions are warmer than the rest of the surface, proof of ongoing geological activity. The heat comes from tidal forces. Saturn's gravity flexes Enceladus, generating friction and warmth. As water rises through the cracks, dissolved gases form bubbles, expanding rapidly and blasting material into space. The Tiger Stripes are windows into Enceladus's ocean, allowing us to sample its depths without drilling. These natural vents have made exploration feasible, turning Enceladus into a focal point for astrobiology. By flying through the plumes, we can study the ocean's chemistry directly. The Tiger Stripes are the key to unlocking Enceladus's secrets. Years after Cassini's final flybys, scientists re-examined its data with new techniques. In 2025, a team led by Nozer Khawaja announced a stunning discovery. The plumes contained a diverse array of complex organic compounds. These included nitrogen and oxygen-bearing molecules, crucial for life's building blocks. Even more remarkable, they found ethers and esters, compounds involved in cell membranes and energy storage on Earth. This suggested a far more complex chemistry in Enceladus's ocean than anyone had imagined. Advanced algorithms revealed these molecules had been hidden in the data all along. The findings shocked the scientific world. Enceladus wasn't just habitable, it was chemically active. The moon's ocean was a cosmic kitchen, cooking up the ingredients for life. The search for extraterrestrial biology had a new, compelling lead. The discovery of complex organics like ethers and esters is a game-changer. Life is built from such molecules. They form cell membranes, store energy, and enable biological functions. Simple organics are common in space, but complex ones are rare and essential for life. Ethers and esters are related to fatty acids, the main components of cell membranes on Earth. Finding them on Enceladus suggests its ocean could form the structures needed for life. Nitrogen and oxygen-bearing compounds are the backbone of amino acids and nucleotides, the building blocks of proteins and DNA. Their presence means the raw materials for life's machinery and information storage are available. The hydrothermal vents at the ocean's floor are likely synthesizing a rich variety of organics, just as on early Earth. Enceladus is a natural laboratory for studying the chemistry that leads to life. It's a world on the edge of biology, perhaps already across the threshold. The implications for astrobiology are profound. For years, Europa was the leading candidate for life in the outer solar system. Like Enceladus, it has a subsurface ocean, but its plumes are rare and hard to sample. Europa's thick ice shell makes direct exploration a monumental challenge. Enceladus, by contrast, blasts samples of its ocean into space, making it far more accessible. Cassini's flybys proved we can study Enceladus's ocean without landing or drilling. This practicality makes Enceladus the best near-term target for astrobiology. Studying both moons will help us understand what makes an ocean world habitable. Comparing their chemistry and environments will refine our search for life elsewhere. Enceladus and Europa are natural experiments, two keys to unlocking the secrets of life in the cosmos. The revelations from Enceladus have reshaped our exploration priorities. Cassini wasn't designed to search for life, but its discoveries demand a return mission. Future spacecraft, like the proposed Enceladus Orbilander, will fly through the plumes with advanced instruments, searching for biosignatures. The ultimate goal: land near a tiger stripe, collect fresh plume fall, and analyze it for signs of life. Such a mission would push technology to its limits, but the potential payoff is immense. Finding life on Enceladus would transform our understanding of biology and our place in the universe. Even if we find only complex chemistry, the insights will be invaluable. The next chapter in the search for life is waiting on the icy plains of Enceladus. Enceladus has taught us not to judge a world by its cover. Beneath its frozen surface lies a dynamic, habitable environment. Its discovery has expanded our imagination, showing that life might thrive in the most unexpected places. If life can exist here, the galaxy could be full of habitable worlds. Whether Enceladus harbors life or not, its story is one of hope, curiosity, and the thrill of discovery. It challenges us to keep exploring, to question our assumptions, and to seek answers in the unknown. This once-forgotten moon now stands as a symbol of cosmic possibility. The next great discovery could be waiting in the icy darkness, just beyond our reach.